Fasko provides a framework to serve, drive, and deploy machine learning models. It bridges the gap between data science and DevOps and enables the team to continuously deliver model prediction services in a fast, repeatable, and scalable manner. Fasko is deployment agnostic and currently supports Kubernetes cluster and AWS SageMaker deployment. Since we are in the midst of a revolution being led by machine learning applications, rolling out of machine learning models in production has been challenging. The trained models produced by a data science team are difficult to test and deploy. This often leads us to a long, error-prone workflow where a pickle model or weights file is handed over to a software engineering team. Fasko is an end-to-end solution for model serving and deployment, making it possible for data science team to ship their models to an artifact that triggers an event to deploy the model automatically. In this video, we are going to train, test, and ship the models and roll them out on AWS SageMaker and Kubernetes cluster. Let's train, test, and ship the models with the help of the Jupyter Lab and the MLflow tracking API. We will launch the MLflow tracking API to record and view the experiments and Jupyter Notebook to run the experiment. Now we will apply a custom Jupyter Notebook template that allows users to fill their content into the code cells. The template is preloaded with the MLflow software package and features to track the experiments and log data to be run. We will test and train a scikit-learn iris classifier model in Jupyter Lab. Let's run the experiment by executing each cell. When compiling and training the model, you can define the tracking URI and the name of the experiment. Place the ML training code under the start run function and save the model as an artifact using MLflow built-in functions. Now that the experiment has finished, we can see the results from the MLflow tracking user interface. Click on the Run to view the result in detail. Scroll to the artifact section to view the output files. You may see that the ML model is saved as one of the output files. After the model is shipped to S3, you can set up an event to automatically trigger the deploy build. Now we will deploy the scikit-learn model on the Kubernetes cluster. Make sure that the AWS EKS cluster is operational and the IAM role is defined on the instance running the Fasko to access the cluster and deploy the model. Return to the MLflow tracking UI. For the demo, we will manually copy the model S3 key and start the deploy build. Navigate to Jenkins and click on Build Job. Click the Build with Parameters button. Select a drop-down value as Kubernetes. Paste S3 key along with the file name. Tag deploy version and let the Docker tag be the default. Now click on the Build button. When the build is complete and the model is deployed on Kubernetes, execute the kubectl command to obtain the service IP address. Copy the URL and open the endpoint in a new tab to test the REST API server. On the Swagger UI, click the Predict API endpoint and provide input data to the API. Click Execute to send the prediction request and get a response of 200. Let's train an experiment with a TensorFlow model. Similar to the earlier notebook template, when compiling and training the model, you can define the tracking URI and the name of the experiment and save the model as an artifact using lock artifact function. Let's run the experiment by executing each cell. Now that the experiment is complete, click on the Run to view the result in detail. Scroll to the Artifact section to view the output files. You may see that the ML model is saved as one of the output files. We will now launch the TensorFlow model on the AWS SageMaker. Return to the MLflow tracking UI. Copy S3 key in the Artifact section. Navigate to Jenkins and click on the Build job. Click the Build with Parameters button. Select a drop-down value as SageMaker. Paste S3 key, tag deploy version, enter the SageMaker endpoint name, and click Build. When the build is complete and the SageMaker deployment service is running, invoke the SageMaker endpoint by passing the base64 URL of the ankle boot image and write the output to JSON file. Open the output file with the VI editor to see the response as ankle boot. In this way, Fasko provides a solution for deploying a large number of models independently with a minimum of engineering and DevOps effort for each deployment.